Welcome to Chapter 2. Today we're going to talk about Sections 1 and 2. (2.1) Objective, learn to identify a rational number in decimal form. 2.2 Objective, learn to write rational numbers as the ratio of two integers. And our essential question, what are rational numbers? So our vocabulary will be rational number and relatively prime. A rational number is any number that can be written as a fraction n over d, where n and d are integers and d does not equal 0. N represents numerator, d represents denominator. To sum it up, a rational number can be written as a fraction. Let's look at the Venn diagram of numbers. These are a set of number systems. We have rational numbers, integers, whole numbers, and natural numbers. You can see on the outside we have the rational numbers. Everything that's inside of the rational numbers would also be considered rational, but they have a more specific characteristic about them. Rational numbers on the outside include 5.4, negative 5/9, negative 0.5, 2 1/3. It's all those numbers that we hadn't discussed in Chapter 1 because they had decimals or they had parts. The integers are what we just got done working with, negative 11, negative 4. Those are the numbers that are whole numbers and their opposites. Okay, so then whole numbers would be 0 and the natural numbers 1, 2, 3. So if it's an integer, it's also a whole number and a natural number. If it's rational, it would be all four categories. So some examples of rational numbers could be something like 1/2. You could write 0.26, and it could be a negative. It could be negative 1 1/8. You could go on and on. Let's talk about factors. Factors are the numbers you multiply together to get another number. So if we were to list factors of 40, they would be 1, 2, 4, 5, 8, 10, 20, and 40. We usually get them by pairing up our factors so that 1 and 40, 2 times 20, 4 times 10, 5 times 8. The goal of simplifying fractions is to make the numerator and denominator relatively prime. And relatively prime means that those numbers have no common factors other than 1. Relatively prime means a fraction is simplified as far as possible. There's nothing that both numbers can be divided by that's the same. So if we wanted to simplify 16/80, we would start by looking at the factors of each number. So the factors of 16 are 1 and 16, 2 and 8, 4 and 4. Factors of 80, you can see those listed. And then we look for the largest factor that they share in common. Well, I see 16 in the list, so we can divide both numerator and denominator by 16, and now we have 1/5. It's, again, the idea of keeping it balanced. We do the same to both the numerator and denominator to keep it equal. Down in our remember box, remember when you have a 0 in the numerator divided by anything except 0, it equals 0. Any number divided by itself equals 1. And anytime the negative is placed with a fraction, it can go in the numerator, it can go in the denominator, or it can go right in the middle. And it all would be equivalent. Okay, 17 and negative 35. When you're simplifying a negative, You don't need to worry about it when you're listing the factors. Just make sure it's part of your final answer. So factors of 17 are 1 and 17. Factors of 35 are 1, 5, 7, and 35. What we notice in our list are we have nothing in common. So that means this is already relatively prime, meaning it is simplified. So there's nothing we can do. Decimals that terminate or repeat are also rational numbers because those numbers can be turned into fractions if we want to. To write a terminating decimal, which means an ending decimal that has an ending number, as a fraction, identify the place value of the digit farthest to the right. Then write all of the digits after the decimal point as the numerator with the place value as the denominator. Remember place values? Here's a few of them. We start with tens and ones on the left, and then when we get to decimals, we have tenths, hundredths, thousandths, and so on. Just an example box of a rational number and its fraction form. So negative 3.2 would be a terminating decimal because it ends, and that would be negative 3 2/10 as a fraction. The rational number 0.13 repeating is also rational and can be written as 2/15. Let's write each decimal as a fraction in simplest form. 5 37/100. If we read the decimals correctly, it's a little bit easier because we hear the place value as we say it. So 5 is the whole number, and 37/100 would be 37 over 100. So in B we have 0 wholes, but we have 622 thousandths. So that turns into 622 over 1,000. Now from there, we should simplify. So going back to example A, 37 only has factors of 1 and 37. And we know 37 does not divide equally into 100, so that is simplified. Now 622 and 1,000 are both even, so we know for sure they can be simplified. So if we don't want to figure out the greatest common factor, we can just pick a factor, such as 2. So if we divide both numbers by 2, we get 311 over 500. Well, we know, okay, 311, that's not going to be divisible by the same things as 500, so that is simplified. Now let's talk about least common denominators. To compare or order rational numbers, first they need to be in the same form, all fractions, all decimals. To compare fractions, find a common denominator. This could be the least common denominator, or LCD, which is the least common multiple of the denominators. So let's compare 5/6 to 7/10. One method is to multiply to get a common denominator. Well, we have the denominators of 6 and 10, so we could just multiply them together and use the number 60. So in order to change 5/6 into a fraction over 60, I have to multiply both parts by 10. In order to change 7/10, I multiply both parts by 6. So I get 50 60ths and 42 60ths. Well, they have the same denominator now, so I'm simply comparing 50 to 42, and 50 is greater than 42. Let's try another method. What do we get if we try cross multiplying? Well, if we go cross as diagonal, 5 times 10 would be 50. And if we go diagonal the opposite way, 6 times 7 would be 42. Do those numbers look familiar? It's no different than just multiplying individually. What you have to make sure of is that when you multiply these cross products, you put the answer in the numerator portion. So feel free to use the cross multiply method instead. Okay, let's compare 1/2 to 2/5. Now think about the number 1/2. We know pretty well what 1/2 looks like. So in terms of 2/5, we would think about what half of 5 is, and half of 5 is 2.5. So we know that 2 out of 5 is less than half. But let's go through the process anyway, just to understand it better. So let's find a common denominator. 2 times 5 is 10, so 10 works. And we get 5/10 and 4/10. Now if we were to go ahead and do that cross product, we would have 1 times 5 is 5. We would get 2 times 2 is 4. And then we'd be comparing 5 to 4, and 5 is greater than 4. So you really have 3 options. Your best option is if you know how to compare the number because you know what it represents, for example, 1/2. Your second option is to get a common denominator. Your third option is to try cross multiplying. Let's compare a decimal to a fraction. When we have a fraction, when we have a decimal and they're different, we want to make sure that we get them to the same form. So whatever way is easier to compare is up to you. I typically think comparing decimals is easier because fractions have to have common denominators. So what I know is that 2/5 is the same as 4/10, and 4/10 is 0.4. So in comparison, when I'm comparing negative 44/100 to negative 4/10, and negative 44/100 would be less than negative 4/10. Make sure your Cornell notes are filled out completely. Review your notes, complete the summary before class, and come prepared to take a formative lesson quiz on how well you understood the material.